Good afternoon. So this is the third session from this chapter, Human Eye and Colorful World. And today we are going to learn about atmospheric refraction and scattering of light. So how many of you are excited? Say hi or say fire, something on the chat so that I'll know you are here, present. Great. So this is about me. If anyone here is new, so this is about me. I have done PhD in physics from National University of Singapore. I have BSMS dual degree from Accompany and I was ranker in IIT. Alright, so चलो start करते हैं आज का पहला टॉपिक. तो ये स्टार क्वेश्चन है. स्टार क्वेश्चंस मतलब हर एक सेशन से पहले I'll try to keep some questions. It could be like competency based question, case study based question, or something which is like a textbook question, like a normal questions. So these are the questions for today, and by the end of the session you will be able to solve or answer all of these. Alright, let's begin. So एक activity करते हैं. This is like a mental activity. This is not the experiment, but we'll do this, and I have prepared specially for you guys. So what is this activity? You see, there is a gradual increase in the refractive index. We have learned refractive index. So these are the different layers. Layer 1, layer 2, layer 3, layer 4, layer 5. And as you go down, the refractive index will keep on increasing. So I'll give you one example. Let's suppose the refractive index here is 1. Refractive index here is, let's say, 0. It is not possible, but I'm just giving you, or else maybe we'll use some better numbers. So let's say refractive index for the top layer is 1. Here it is 1.1. Then refractive index is 1.2. Refractive index here is 1.3. Refractive index here is 1.4 and 1.5. So there is a gradual increase in the refractive index, correct? So now let's suppose there is an incident ray of light which is incident from, there is like a vacuum, correct? From the vacuum it is entering. So now at this point I can draw a normal, correct? Normal is making an angle 90 degree. Correct, there is an angle 90 degree. So now will it bend towards normal or away from the normal? What do you think? It will bend. You see, there is a slight bending towards the normal. Ray is getting bent inside, inwards. Can you see here? Bending inside. So now when you go from layer 1 to layer 2, again you are going from optically rarer medium to optically denser medium. Again क्या हो रहा है? It is bending towards normal. Can you see? It will keep on bending towards the normal. Is it visible? Continuously it is bending towards the normal. So now let's suppose if there is an observer here at this location, and let's suppose there is some star here. So this star, there is a real position of the star, but it will appear somewhere else. Where will it appear? There is a original star real position, but the star will appear somewhere else, correct? So this phenomena is nothing but our atmospheric refraction. So I'll tell you again in the perspective of our earth. So this is our earth, the brown color one, and outside the earth there is an atmospheric layer, correct? And can you see, when you go out, the density of the particles is keep on reducing. So there is like a vacuum here, correct? And there is a surface of the earth. So now if let's say you go from vacuum to the surface, the number density of the molecule keep on increasing, and because of that क्या हो रहा है, यहाँ पे जो optical density है, as you go closer to the earth, optical density will keep on increasing. So now let's suppose there is a star here. So the ray will come from the star. Let's suppose there is our sun. So there is a sunlight coming from the sun, something like this, but as soon as it crosses this point, it will keep on bending towards the normal. There is a gradual bending, correct? And there is the real position of the sun, but what is the apparent position? There is the apparent position. So when you look at the sky, and let's suppose there is a sun or some star which are near the horizon, so there will be some shift in their real and apparent position. By the way, do you know what is horizon? some of you are confused. Even I didn't know what is horizon. So let's suppose if you are on the beach. So if you go to the beach, then you look at the sea. So there is somewhere at the very far, the sea surface and the sky appear to meet. That position or that point is called as horizon. The horizon is the farthest point that you can see, farthest point on the surface of the earth. Correct? So now what is atmospheric refraction? It is due to gradual change in the refractive index of the atmosphere. This is called as atmospheric refraction. Clear? Very straightforward, very simple. Alright. So now there are different phenomena that happen due to atmospheric refraction. So what are those? Firstly, the stars near the horizon appear slightly higher than their actual position. Second one, there is an advanced sunrise and delayed sunset. We are going to learn all these. I'm just telling you. Apparent flattening of the sun's disk. So let's understand these three phenomena that are happening due to atmospheric refraction. So the first one, you see there is the actual position of the sun, but because as the light passes through the atmosphere, there is a gradual bending of the light. Light will keep on bending gradually. Let's suppose there are 2 points here. There is a top point and the bottom point. Can you tell me? So which light ray will bend the more? The top one is the top and bottom. The light ray coming from the bottom will bend more, or the light ray coming from the top of the sun will bend more. What do you think? बताओ जल्दी से. फातिमा, संजना, नागा. Hi Naga, Shaina. You are after long time. Manohar, let's answer. Okay, so now you see this ray coming from the top. It is covering this much distance approximately, right? But the ray which is coming from the bottom, there is a ray coming from the bottom. It is covering larger distance. So the one which is coming from the bottom is traveling larger distance or traveling longer distance through the atmosphere. So because of that, the one which is coming from the bottom will bend more. The one which is coming from the top will bend less. So let's suppose there are different positions of the sun. There is a sun at the horizon, there is a sun somewhere in the sky, and there is a sun like 12 noon. Sun at 12 noon. So if the light is coming from this sun, will there be any bending? No, there won't be much bending, because there is like a coming straight. The angle of incidence here, angle I, is 0 degree. So if the angle of incidence is 0 degree, there will not be much bending. So when the sun is at the noon, there won't be any shift in the real and the apparent position. But whenever sun is near the horizon, there will be a shift in the apparent and real position. Yes, Dhar, Vivedi, I'll talk in both English as well as Hindi. I'll talk in both, okay? Because there are some students which prefer English and कुछ बच्चे ऐसे होते हैं जिनको हिंदी पसंद है, तो दोनों मिक्स करके बोलूंगा, ठीक है, ताकि सबको पता चले, सबको समझ में आ जाए. तो अभी ये कोई स्टार है, फॉर एग्जाम्पल नॉर्थ स्टार और सम स्टार. सो दिस स्टार इज नियर द होराइजन. तो अगर ये स्टार, कोई भी स्टार जो होराइजन के क्लोज है, तो उसका क्या होगा? द लाइट कमिंग फ्रॉम द स्टार as it enters the atmosphere, there is our atmosphere of the earth. As light enters the atmosphere, there is a bending. लाइट क्या हो रही है? बेंड हो रही है. जैसे ही एटमॉस्फेयर के अंदर लाइट एंटर होती है, यू सी देयर इज अ स्लाइट बेंडिंग, और उस बेंडिंग की वजह से क्या होता है? देयर इज अ रियल पोजीशन ऑफ द स्टार एंड देयर इज अ अपैरेंट पोजीशन. अपैरेंट मतलब हमें दिखता है, वो एक्चुअल में नीचे होता है होराइजन के, कोई भी स्टार या सन, बट रियल में नीचे होता है. बट अपैरेंट मतलब वो हमें लगता है कि वो इट इज अबव दी होराइजन. ओके, समझ में आ रहा है आपको? आई एम नॉट फ्रॉम साउथ, आई एम फ्रॉम पुणे. Yeah, Pune, I don't know whether it is south or north. It is like in the center or western of the India. Alright, so stars near the horizon, they appear slightly higher than their actual position. So अभी क्या होगा, अभी अगर यहाँ पे स्टार की जगह पे कोई सन है, like our own sun, तो ड्यूरिंग सनराइज और ड्यूरिंग सनसेट दो चीजें होती है. When there is a sunrise, there is a real position. Sun is below the horizon. So ideally, you should not see the sun. But real में क्या होता है? Because of this bending of light, sun will appear somewhere up. So there is an apparent position. And same thing happens for the sunset. Sun is already gone below the horizon. But because of this bending of light, because of the atmospheric refraction, sun will appear above the horizon. So there is a 2-minute delay in the sunset and 2 minutes. So sun is visible 2 minutes before the sunrise and there is a 2 minutes of delay after the sunset. So total duration of the day will be increased by how many minutes? 2 minutes here and 2 minutes here. Sun will be in the sky totally for 4 minutes extra than it should be, and this is due to the atmosphere. Okay? All right. चलो अभी ये समझ में आ गया आपको, तो नेक्स्ट कंसेप्ट पढ़ते हैं. अभी ये फ्लैटनिंग ऑफ द सन्स डिस्क, इसका मीनिंग क्या है? जैसे सन आपको दिखता है, इफ यू लुक एट द सन ड्यूरिंग द डे टाइम, तो सन इट इज लाइक अ परफेक्ट सर्कुलर शेप, करेक्ट? बट एक्चुअल में when there is a sunset or sunrise, sun doesn't look like a perfect circle. वो एकदम सर्कल शेप में नहीं होता है, it is different. sun कैसे दिखता है? Something like this. So if I divide this into two half, let's suppose there is a top half, upper half and the bottom half. So the upper half looks almost like a circular shape, but the bottom half, it should be like this. But there is something which is not circular. It is not a circular shape. So ऐसा क्यों हो रहा है? मैंने 2 मिनट पहले आपको पूछा था. Let's suppose there is a ray coming from the top surface of the sun. There is a top surface of the sun and this is the bottom surface. So the ray coming from the bottom surface. So कौन सा ray ज़्यादा bend होगा? Bottom surface से जो आ रहा है या top surface से जो आ रहा है? The ray which will bend more will be coming from the bottom layer of the sun. So this ray will bend more. So there is an uneven bending. The bending of these two rays is not same. So there is a uneven bending of the light coming from the sun, and this is the reason for the flattening of the sun's disk. So it is not perfectly circular shape. So the top half, you can see the top layer, top half, it looks almost like a circular shape, but the bottom half, it is slightly smaller than the circular shape, smaller than the semicircle. Correct? समझ में आ रहा है आपको? Great. So now answer this question. So there are stars at different location in the sky. So which will show maximum deviation from the origin position due to atmospheric refraction. So atmospheric refraction की वजह से कौन सा position में there will be maximum deviation. So that is a maximum change in the apparent and the real position of the star. आपको hint दो एक? चलो, this is a hint. So there is a position C, position B and position A. There is like a 12 noon. This one would be like somewhere like a 9 a.m. and this one would be something like a 6 a.m. Star or the sun at the 6 a.m., 9 a.m., 12 noon, or 6 p.m., 9 p.m., 12 midnight. So which one will have maximum deviation? So the position at A, there is no deviation. The apparent and the real position are same. If the star is like 9 AM or 9 PM, there is a slight deviation. But when the star is here, there is a maximum deviation. So when is the maximum deviation? When the star is near horizon. So the option should be star directly above the ground, that is wrong. Then stars at the horizon, that is correct. Same deviation for all the stars, that is not correct. And how about the last one? Stars which are closer to Earth. So which is the closest one? Sun. There will be shift in the rays coming from the sun. But even the stars which are very far away from other galaxies, still you will see the deviation. So this is also not correct. Clear? Yes, some of you are getting correct answers. Nice. Great. Now, let's suppose we have different temperature of the air. Like there is a winter, there is a summer, or different layers in the atmosphere, and they have different temperature. So now question is, cold air behaves as optically rarer or denser, or you can't say. Is there any relationship between the temperature of the air and the optical density? So what will happen? Let's suppose the air is cold. So it will be dense, colder would be denser. If it is hot, what will happen? If you give enough temperature to the water, water will boil and it will evaporate. So once it evaporates, it goes up. If it is cooler, it will come down, correct? So the colder air will be denser. It will have lot of molecules, lot of gases, and because of that, it would be optically denser. So cold air will have greater refractive index. The hot air will have low refractive index. Remember this: cold, higher refractive index. That is the meaning of optically denser. Okay. So now because of that, something like this happens. Have you seen the air which is just above the fire? It appear to be like it is moving. Or let's suppose if there is some house behind it, that house will appear to move. Why does it happen? Have you seen this? Have you observed this? किसी ने देखा है ऐसा कि जैसे ही फायर कुछ जल रहा है, कुछ बर्न हो रहा है, तो उसके ऊपर का जो एयर है, इट कीप्स ऑन मूविंग, एंड उसकी वजह से अगर कोई ट्री या कोई हाउस है जो कि उस फायर से बियॉन्ड है, तो वो थोड़ा सा ऐसे शिफ्ट होता हुआ दिखता है ना? इट कीप्स ऑन मूविंग. सो व्हाई इज दैट? किसी को पता है? सो क्या होता है, इफ यू बर्न समथिंग, द एयर विच इज नियर this will become hot. Hot air is lighter. So hot air will, so let's suppose there is a fire. So above the fire, hot air will go up, hot air, and the cold air from the surrounding will come here in this direction. Correct? Hot air will go up because hot air would be lighter. The cold air is denser. It will come here and occupy the space above the fire. So when there is a constant shift in this motion of the air, what happens to the air which is just above? The refractive index will keep on changing. Sometimes the refractive index is low when it is hot. When the air is hot, refractive index is low. As soon as some cold air comes and occupy the space, refractive index increase. So there is this medium which is the air, there is a constant change in the refractive index. So if the medium is changing, if there is a constant change in the refractive index, the object which is beyond this will appear to move, and this is called as apparent flickering. So do you know direct example or direct application of this apparent flickering? Okay, I'll tell you the application. Have you seen in the sky some stars which are constantly twinkling. So do you know reason why some stars are twinkling? There are some stars, for example this one or this one, they are not twinkling. Some of them they are twinkling and some are not twinkling. So let's understand first the ones which are twinkling, why they are twinkling, why there is a twinkling of the stars. Let's understand this. So what happens when the air goes through the atmosphere? It passes through the atmosphere, and air is not constant. Air is not like a glass. It is not a fixed. Air हमेशा move करती रहती है, right? हमेशा से air move करेगी, और उसकी वजह से क्या होगा, air जब भी ऐसे move करेगी, sometimes यहाँ पे कुछ pockets होंगे which is a hot air and कुछ pockets ऐसे होंगे which is a cold air. So there is a constant change in the temperature. कहीं से cold air आ जाएगी, ठंडी हवा आ जाएगी, कहीं से hot air आ जाएगी, right? So जो atmosphere है, it is constantly changing. तो उसका जो refractive index है, it is not fixed. And because of that, क्या होता है, जो light star से जो आ रही है ना, there is not a straight path. वो ऐसे straight path में हमारे पास नहीं आ रही है. Sometimes it is going away. For example, let's suppose there is a surface of the earth. There is a person standing here. Okay, there is an observer. Correct? And there is a star here. So sometimes light is coming something like this. But because of some phenomena, some natural movement of the air, let's suppose यहाँ पे कहीं पे थोड़ा सा hot air आ गई, and because of that ये जो ray ना, ray went somewhere else. तो sometimes क्या होगा, ये सारा जो light है observer के पास आएगा, और sometimes क्या होगा, some of the light will be away. It will not reach the observer. हम चीजें देख क्यों सकते हैं, कोई भी ऑब्जेक्ट हमें दिखता क्यों है, because either that object is producing light, it is luminescent, for example sun or the stars, so they produce light and the light falls onto our ear, our retina, sorry, our eyes and the retina, correct? Or some objects are reflecting the light and that light will fall onto our retina. So now if the light do not fall, do not come to me, if the light goes somewhere else, I won't be able to see that object, correct? So that's what happens. So sometimes the air is continuously changing, and because of that, because of the continuous change, there is a change in the optical density or change in the refractive index. Refractive index क्या होती है, हमेशा change होती रहती है air की, and because of that sometimes star will appear brighter. Brighter कब दिखेगा, जब more light will refract towards us, बहुत ज़्यादा light हमारे पास आती है, then it will be brighter, correct? And sometimes it is fainter. Sometimes that star will be fainter. कब faint दिखेगा, जब light जो आ रही है because of some movement of the air, कोई light किसी और जगह पे चली गई, so it does not come to me. So that is the reason it will appear fainter, correct? And that is the reason for the twinkling of the eye or twinkling of the stars. So again यहाँ पे देखो आप, ये जो star है, it is twinkling. So sometimes it is brighter. Brighter means more light from the star is reaching to me. If it is fainter, that means some part of that light is going away from me. So that is why sometimes it is fainter, sometimes it is brighter. Clear? Yes, you can ask your doubts. If I get time, I'll try to answer your doubts, okay? Okay, so this is the reason for the twinkling of the stars. Clear hai sabko? Great. So now answer this question. So which of the following is not correct? You have to find the statement which is not correct. Apparent shift, okay? Yes. All right. So आपने पढ़ा होगा ना stars and planets. So first statement, planets are larger in size than stars. Is this correct? Planets are larger in size than stars. Second statement, planets are closer to us compared to stars. Is this true? Yeah, this statement is true. I'll write here, these are true. Third number, planets appear larger than the stars. In the sky, if you look at the sky, planets appear larger. This is true. Why planets appear larger? Because they are closer. Planets are closer. है ना? Planets बहुत close है. The nearest star to us is Sun. But after that, the second nearest star is Proxima Centauri, which is like quite far, which is outside our solar system. Correct? So the stars are very far. They are much larger than our Sun or our Earth, but they are very far. So is this correct statement? First one, planets are larger in size. This one is not correct. We want to find not correct. How about the last statement? Stars appear to be point size objects in the sky. This one is true. Why this is true? Because planets are very 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 far. तो जो light planets आ रही है हमारे पास, it will appear in the sky like a small tiny object or the point size objects. हमने पढ़ा था ना जब लेंस या मिरर पढ़ते थे, whenever the light coming from the far object, it will appear to be a point size. So exactly similar thing is happening here. Okay, so there is a refraction. When the light comes fall onto our eye, it will be the image which is formed on our retina. This will be the point size image. So that is the reason the stars appear, they are not exactly point size, but they appear to be point size objects in the sky. Yes, A is wrong, correct. So now because of this something interesting happens. So there is a star which is a point size object. The planets are very close. So planets are not point size object. They will appear much larger in size. And because of that, what happens? Stars are point sources of light. Planets are extended sources of light. Extended meaning कुछ बड़ा object है. It is not a point size. It has certain, if you measure, it will have certain diameter. For the stars, you can't even measure the diameter. They are too small. But for planets, you can measure. And because of that, what happens? The variation of the light coming from the planet average out. So stars will appear to twinkle, but the planets do not twinkle. So if you look at the sky, okay, I'll go back. If you look at the sky, for example, some objects are not twinkling. So the ones which are not twinkling, for example, these ones, they are not twinkling, they are planets. So the objects which are not twinkling in the sky, these are planets. Correct. Yes. So why planets do not twinkle? Because planets are very close to us compared to the stars. So these are extended source of light. And so the variation of light that is coming or that is reflected from the planet average out to 0. So there is not much variation in the light. So that is why they do not twinkle. Yeah, they don't have their own light, but they reflect light, correct? They reflect the light and they are extended source. That is the same reason why moon or the sun also do not twinkle. Why the moon and sun do not twinkle? They are very close and the overall intensity average out to 0. Your dream is to get 100%. Awesome. Great. All the best. All right. Solve this question. Total duration of the day increased by dash minutes due to advanced sunrise and delayed sunset. So due to advanced sunset, duration of the day will increase by 2 minutes, correct? And due to delayed sunset, the duration will increase by 2 minutes. So the total duration would be addition of these two. So if you add these two, the total duration will increase by 4 minutes. Clear? Yes, you have to add these two. Okay. So now the colder layer of air present in the atmosphere considered as a optically denser, optically rarer, optically opaque or crystalline. You remember I told you cold layer or the cold air will be denser. It will have a lot of molecules, lot of gases. So if it is denser, it will be optically denser. Optically denser meaning higher refractive index. That is the meaning of optically denser. Clear abhi? Great. So now planets do not twinkle, that is the assertion, and reason is light rays do not come from the planets. What do you think so? Is the assertion correct? Planets do not twinkle. This is correct. Light rays do not come from the planet. This is not correct. This reason is wrong. Why it is wrong? Planets do not produce their light, but they can reflect the light. Reflection also they will give the rays. They will reflect the rays towards us. So the reason is wrong. So now tell me which one is correct? Assertion is true, but reason is false. It is option number D or 4, whatever. Okay? Clear? Sabko? Great. So now let's understand two more effects, that is scattering of light and Tyndall effect. These are quite important. So pay attention. I'll go very slowly and try to explain. So you must have seen in forest the path of light, you see, path of the light is clearly visible, or in your olden houses the path of the light is clearly visible. In our houses, like if your house is very clean, modern house, we do not see this. If you open the window, we do not see the path of light. But if you go to very old house, or if you go to the forest, we see this path of light. So this path of light is the reason of Tyndall effect. Correct? So there is a diffused reflection. So it is not a complete reflection. In the reflection, we have the, what is the reflection? Okay, we don't have space here. Okay, what is the reflection? In the reflection, we have a flat surface. For example, mirror. Mirror reflects the light. It is a flat surface. But let's suppose there are particles, like dust particles or air molecules. So if the light falls onto it, there is no, light can go anywhere, correct? Light can go anywhere. So this is called as diffuse reflection. We'll study that. And this is what happens. So you observe this experiment. So there are two beakers. In the one beaker, there is a laser light, and laser is passing through both of the beaker. So there is a clear solution. Clear solution. So like a clean water. And this one, you add some salts, or you add something which will suspend. This is a colloidal solution. So if you pass the laser beam, so here no laser beam will be seen, but in the colloidal solution you see the laser beam. Correct? You see here, there is a clear solution, no ray of light visible, but in the colloidal solution you see the beam of light. So why does it appear? So what happens when the light, when this flashlight or laser light falls onto the suspended particles, there is a diffused reflection, and this diffused reflection will show us the path of light, and this phenomena is called as Tyndall effect. So when the scattering of light by the colloidal particles present in the solution, when the light falls onto it, there is a diffused reflection or scattering of light, and because of that the beam is visible. Beam or the path of the light is visible. This is called as Tyndall effect. Okay? So now solve this question. Here is ABCD. A, B, C, D, 4 options. Hi, Saurabh, Shaina, Sujata, Huzaifa, Siddiqui. Hello everyone. Nice. So assertion is we cannot observe the Tyndall effect in the clean room, and the reason is Tyndall effect required dust particles suspended in the air. So is the assertion correct? Yes, assertion is correct. We cannot see if it is a clean room, like our houses, they are pretty clean. If you are living in a good society, it would be pretty clean. You won't be able to see any Tyndall effect. That means the ray of light or the path of light is not visible, and Tyndall effect requires dust particles suspended in the air. This is also correct. So reason is not just correct, it is the correct explanation of the assertion. So it is option number A. Right? Awesome, all of you. Great. Aditi, correct. So now the last topic, that is the scattering of light. You see here the beautiful image, the animation. So there is a one just single photon or the ray of light. When this ray falls onto these small particles, you see it gets scattered. Scatter means this single photon will diverge in all the possible directions. So this phenomena is called as scattering of light. You see again the single ray of light. Wait, what are these? So these are nothing but particles. It can be dust particle, can be molecules which are present in the air. So when the light falls onto it, it spreads all over. Correct. Spreading is not scientifically correct. The scattering is a scientifically correct word. Okay. Light will be diffused in all the directions. Yes. So when the incident beam falls onto the small particles, it will be diffused or scattered. Scattered is the, like, there is no direct translation of this word. This is the correct scientific word. Light gets scattered in all the possible directions. Correct. And there is a phenomena called as Rayleigh scattering. So this is the name of the scientist who discovered this phenomena. So what he said, the scattering is inversely proportional to lambda raised to 4. What is the lambda? We have seen in the last video, last class, lambda is a wavelength of different colors. So these are the different colors, they have different wavelength. For the red has the maximum wavelength, the violet has the minimum wavelength. So can you tell me which color of the light will be scattered the most? Which color will be scattered the most? Is it the red, orange, yellow, green, blue, indigo, or the violet? So if you want more scattering, wavelength should be lower. Lower wavelength, maximum scattering. Remember this, lower wavelength, maximum scattering. So lower wavelength is the violet color. So violet color will be scattered the most and the red color will be scattered the least. Usually these three, I'll write down here, red, orange, yellow, they are least scattered. Least scattered. And the rest three, which is blue, indigo, violet, they are most scattered. Blue, indigo, violet will be the scattered the most. Red, orange, yellow are least scattered. Okay. So these are the different wavelength. You see the red one has the maximum wavelength. The violet one has the minimum wavelength. So now it is falling on the large particle. What are large particle? Like a dust particle or the hair. These are large particle. Then this Rayleigh scattering is not valid. So all the colors are scattered equally. All the colors get scattered equally. But let's say if the particle is small. Small particle. What are small particle? Like atoms or molecules. Nitrogen, oxygen. These are the molecules present in the air. If the light falls onto the small particle, then it will follow the Rayleigh scattering. So these colors, blue, indigo, violet, will be the scattered most. Okay. So now there is a source of light falling onto different particles, the long wavelengths that are orange or red will pass through without any scattering. The smaller wavelength will be scattered. Correct? The red light will pass without much scattering, but the blue light or the violet light will be scattered. Correct? And this is the reason for different colors that we see in nature. So let's understand that different colors in the nature. So first question, why the color of the sky, clear sky, is blue? Can you tell me why sky is blue? Anyone, do you know? Okay, these are the molecules or the gases present in the atmosphere, correct? Nitrogen, oxygen, CO2, these are the tiny particles. These are the molecules or the gases, and all the other water droplets, dust particles, smoke, these are large particles. If the light fall on these, what will happen? Large particles, all the colors will be scattered equally. So it is equal scattering for all the colors. But if the light falls onto these tiny particles, which are the molecules or the gases, then blue, indigo, violet, these colors will be scattered most. Scattered most. Correct? You can see here, when the red light is coming, falling on the particle, most of the light will pass without much scattering. But if it is a blue light, it will scatter all over the place. So now, my question to you is, when the light comes from the sun, violet has the minimum wavelength, correct? Red has the maximum wavelength. So red does not scatter, but violet should scatter the most. So why the color of the sky is not violet color? Why is it blue? Yeah, these three, blue, indigo, violet, they will be scattered. But why the color of the sky is not violet? Why is it blue? These blue light will be scattered, red light do not scatter. So now there is a question. Violet and indigo, they have smaller wavelength than the blue color. Why sky doesn't look violet colored? There is a question. Do you know a reason for that? How many of you know? Okay, there are two reasons for it. First reason, our eyes are sensitive to, there is a blue color and violet color. Can you see blue color easily? Yes, we can see the blue color easily. Is the violet color visible clearly? No. Our eyes are not sensitive to this violet color. And there is a second reason, that the spectrum of the sun, that means all the light that is coming from the sun, the intensity of the blue color, there is a blue color and this one is the violet color. The intensity of the blue color is much greater than the violet color. Violet color do not have that much intensity. That is why the incoming radiation or the incoming rays from the sun do not have much violet light. So even if it is scattered the most, you won't see that in the sky. And in addition to that, our eyes are not sensitive to violet color. So that is the reason we'll see the sky as blue. Understood? Solve this. So the moon, our moon, does not have any atmosphere. So what will be the color of the sky on the moon? I'll give you a hint. You want hint? So there is a surface of the moon, there is a surface of the moon, and this is how the sky will look from the surface of the moon. And it should be black colored. Because there is no atmosphere, so there is no scattering of the light. So the sky will appear to be black colored, no scattering, correct? Next one, when there is a lot of pollution, so these particles are present in the air, dust, smoke. So what is the color of the sky? So these particles, dust and smoke, these are large particles. So they will scatter the light equally in equal amount. So if the light is scattered equally, all the colors are scattered equally, what will be the color of the sky? So sky will appear something like this. This white color. This is not black, this is white color, and there is a grayish tinge because of the carbon particles. There are some carbon molecules, they will give this grayish color, but ideally the sky becomes white in color because all the colors, they get scattered equally, and we have learnt recombination. So if all the colors are scattered equally, they will recombine and form the white light. Understood? Next one, why the clouds are white in color? You see the clouds like cotton, perfectly white in color. Why the color is white? And the reason for that, the clouds consist of water droplets and ice crystals. So these are large particles. So if the light falls onto this, all the colors or all the wavelengths are scattered equally. तो सारे जो wavelengths है, they will get scattered equally, and because of that, if there is equal scattering, they will recombine. All the colors will recombine and they will form white light, and that is the reason clouds will appear white in color. That is the same reason milk will appear white in color. So milk has large particles. There are some proteins, some fats present in the milk. So these are like a large particles. When the light falls onto the milk, onto these particles, it will be scattered equally. It will recombine and form the white light. Okay. So now next question, why the oceans are blue? Who are you? I am your teacher. I teach physics at Infinity Learn. So why the oceans are blue in color? This is an ocean. I used to think ocean looks blue because of the reflection of the sky. Is this correct? No, it is not correct. Oceans are not blue because of the reflection of light. There is something else. It is the scattering of light. So ocean will have water, correct? But is it a large particle or the small particle? So this water is in the liquid form. These are not particles. These are not water droplets. These are one uniform medium. One uniform medium. So when the light falls onto these water molecules, the colors that are blue, indigo, violet will be scattered the most. That is the first statement. Second statement, the red color will be absorbed by these water molecules. Water molecule absorb the red color. So these two reasons gives the color to the gives blue color to the ocean. Firstly, there is a scattering of light. Blue color will be scattered the most. Blue, indigo, same reason. Blue, indigo, violet will be scattered the most, but then these two are not sensitive to our eyes. Which one is sensitive? Blue color. And in addition to that, the red color, red light will be absorbed by these water molecules. So what is left? We are left with only blue color, most predominantly. So that is the reason the ocean looks or appear to be blue color. Okay, solve this. Live session for the 9th. Okay, I'll tell them to arrange. All right. Total internal reflection, that is not correct, Ankur. For the total internal reflection, light should come from the optically denser medium, not from the rarer medium. So okay, sky would have appeared dash color if Earth doesn't have the atmosphere. So there is the same situation for the moon. Moon does not have atmosphere, no atmosphere. So if there is no atmosphere, sky would have appeared black colored. No atmosphere, black color. Next one. Color of the scattered light depends on which of the property of the particles. Density of particles, quality of particles, size of particles, none of these. I told you, right? You remember large particles and the small particles. So how do you decide whether particle is larger or smaller? So the size or the diameter, if there is a diameter is greater than wavelength, then we call them as a large particle. If the diameter is smaller than the wavelength, then we call them as a small particles. So these are like small particles would be gases like nitrogen, oxygen molecules or air. Large particle would be dust particles, correct? So it is the size of the particles on which the scattering of the light depends on. Okay. Now there is, I think, last or second last question, almost towards the end. So danger signal, you have seen on the top of the building they have the red color, correct? All the danger signals on the tall buildings are red color. So what is the reason for that? These can be seen easily from a distance because among all the colors, red light will be, is it scattered the most, scattered the least, absorbed the most, or moves fastest in the air? The correct reason is the red light will be scattered the least. So because it does not scatter, it can travel longer distance without getting scattered. So that is the reason on the top of the buildings we have red light, or even on the behind the cars we usually have the red lights. It is the same reason. Red light is the least scattered. Okay. All right. At noon sun appears as a white because light is least scattered. All the colors of the white light are scattered away. Blue color scattered the most. Red color is scattered the most. What do you think? At noon, that means if there is a surface of the earth, our sun is directly above. So there is an atmosphere, correct? So light is directly coming from the sun. So in that situation, light is least scattered during the noon time. When the sun is directly above, light will be least scattered, and that is the reason sun will appear whitish or yellowish. So there is not much scattering. Okay. I think there is a last question. Clear sky appears blue. Clear sky appears blue in color because of blue lights is absorbed in the atmosphere. Ultraviolet radiations are absorbed in the atmosphere. Violet and blue are scattered more than other colors. Light of other colors is scattered more than violet and other colors. And the correct reason is option number 3. The violet and blue lights are scattered most than the other colors, and violet is not sensitive to our eyes. Which is sensitive? Blue color is sensitive to our eyes. So that is the reason sky appears blue in color. Okay. Alright, so we have answered all these questions. If you have any doubts, any questions, do share in the chat, and there is a Telegram channel. Do follow this Telegram channel. You will get all the updates, all the notes, whatever we have learned. I hope you have understood, and all the best for your exams. So from tomorrow, we'll start with electricity chapter. I am quite sure most of you have a lot of questions regarding electricity. समझ में नहीं आता है सर, पोटेंशियल डिफरेंस क्या होता है और वोल्टेज क्या होता है, क्यों करंट फ्लो होता है सर्किट में, कुछ पता नहीं है. So if you have these questions, come tomorrow, we'll discuss that. Okay, bye bye, thank you so much, enjoy everyone. आशिक बंद करो, हो गया.